Pac-Man, an age-old classical game of avoiding ghosts, chasing a higher and higher score so you can brag to all your friends. How nostalgic. Yeah, no, we're ruining it with AI. Hey everyone, in this video I'm going to train an AI to play Pac-Man. The technique I'm going to be using to train the AI is known as reinforcement learning. I'll be releasing a video series soon about the full details behind how to create neural networks, customize environments, build your own models, the raw mathematics, and other parts of what makes up a reinforcement learning AI. But to understand how we're abusing the little yellow guy today, here's what you need to know. Reinforcement learning AIs start off as blank slates. The object the AI is running on is called an environment, in our case, the game. To play the game, the computer creates a player called an agent. Programmers decide what kind of possible moves the agent can take, like moving up or down, and they also define to the agent what kind of things are good and what are bad. For example, when Pac-Man eats a fruit, he gets a lot of points in the game, so we reward the agent. When Pac-Man hits a ghost and dies, we punish the agent. The goal of the agent is to maximize its reward, and how it does that depends on what kind of model or learning method you tell the agent to use. Eventually, the idea is that the agent will learn what actions lead to positive results and what actions lead to negative results, and the computer learns how to play the game better than any human ever could or will in the future. Now let's get down to actually training Pac-Man. Conveniently, OpenAI Gymnasium has prepared various test environments and agents already built, one of which is Pac-Man. This makes it so we don't have to code the entire game and set the reward weightage ourselves. Additionally, Stable Baselines 3 has already built general AI models like the PPO, or Proximal Policy Optimization model, so we also don't need to design a neural network for this project. Thanks to that, this is pretty much all the code we need right now. This is the AI running with absolutely no training. It's basically just a random bot. The AI randomly selects an action from its list of possible actions, and pretty much just hopes for the best as it watches what happens. You can see evidence of this by how jittery it is. Pac-Man is practically cycling through all of his options really quickly, making him go back and forth. He also doesn't know how to really avoid ghosts yet, so he dies pretty fast. Now I could let this AI train for a while, but first I want to update the code for a bit. We want the AI to be able to save the model it makes every time it's done with a session of training. Since this Pac-Man model defaults to using 2048 increments by OpenAI's design, let's save after every 2048 time steps. Finally, if we start training again, we want to be able to pick up where we left off, so we also add in a clause to load our most recent model. Yeah, no, the AI isn't working so great. Somehow or another, Pac-Man always seems to learn that ramming his head straight into a wall like this is the best option, even if it kills him. I tried training it a few more times, but it didn't work so great. Solving these kinds of issues is where reinforcement learning gets difficult. Maybe the issue is we just didn't let Pac-Man train long enough? Even though I did this. Usually these kinds of AIs are trained for millions and millions of time steps on the scale of days, not the couple hours I did today. Maybe the issue is the model itself. There are 7 or 8 different models Stable Baselines 3 is offering. Each one of them trains the AI using different techniques. Maybe hyperparameter tuning was wrong. You could encourage exploration more or less. After a lot of testing and playing around, I modified the code to look like this. I changed the hyperparameters to encourage exploring the map and prioritizing future rewards. I also eventually decided to stick to PPO because it seemed to be doing the best. And after a lot more training, here's the final result. Admittedly, that was heavily influenced by luck, but still, over 2000 is a really good score for an AI on just 6 or 7 hours of training. This model still did perform much better overall though. It explores more pathways, gets higher scores, and even actively avoids ghosts. Still loves kissing walls though.